Hello, and welcome to the section on seismic loads. So the basis for seismic loads will come from ASC 7. And in our case, I'm doing all the references based on the 2010 version, so ASC 7-10. And similar to our wind load selection, we are just finding the loading, and we're not yet diving into the actual lateral force resisting system or seismic force resisting system for the bridge yet. That will come in later sections and is not exactly something you're designing. We're mostly just checking the adequacy of the design based on the seismic loading that we determine in this section. So the learning objectives are follows. We want to, 1, understand the equivalent lateral force procedure. 2, understand the basic design principles behind seismic design, seismic load analysis. And 3, familiarize yourself with the advanced methods that we would be using for seismic design in, say, a skyscraper or a larger vehicular bridge. So I'll link a video below, which is a great introduction to the terminology for using the response spectrum method. And following this, I'll go into detail about the variables and how to use the equivalent lateral force procedure that I just mentioned. So watch the next video and then watch the series of videos about the lateral force, the equivalent lateral force procedure. So in those videos, we're going to use this procedure, which essentially turns an earthquake into a static loading on the structure. Based on material type, location, soil type, risk category, and more, we can equivocate a short and long seismic motion into equivalent base shears that move up or along the structure. And here's a diagram you might have seen in school that kind of shows how that shear moves up the structure, where it's going to be kind of the inverse of, say, soil pressure, where the greatest load is at the top because that's where we're going to experience the largest acceleration. And remember, force equals mass times acceleration. So more advanced analyses are recommended if the bridge is being built in a known active seismic zone. The following sections are really just helping you understand the basic concepts and the basis behind determining a seismic load. And you would really want to be doing some sort of numerical or software modeling because the structure is so irregular. It is hard to analyze just like a building, because we have a flexible cable structure as well as a very rigid abutment structure. So modeling how these interact would be really helpful with software and is likely going to be complex and difficult and following a lot of assumptions if we're just doing this with the, say, equivalent lateral force procedure.